Let's talk about galaxies, more specifically spiral galaxies. But before we can grasp that, let's make sure we are all on the same page. There are two concepts that are central to the formation of spiral galaxies, namely Moire patterns and precession. Let's tackle precession first. You've all seen a spinning top that wobbles in a predictable way. When the top is tilted, gravity creates torque. Instead of just falling over, angular momentum of the spin creates precession. Stars in elliptical orbits don't stay in one fixed path forever, and their orbits can precess, as seen here. For stars in a galaxy, elliptical orbits stick closely to Newtonian rules and precession. The Sun has a galactic year or one rotation around the Milky Way in about 240 million years. Precession is an incredibly slow process in large galaxies, and our Sun is estimated to have rotated around the Milky Way only 57 times in 13.6 billion years. Watch this: stars, gas, and dust zooming around a galaxy's center, not in perfect circles but in stretched-out elliptical paths. These orbits are all lined up at its formation and overlapping, each one tugging on its neighbors through gravity. I just love spiral galaxies, always have. Those cosmic pinwheels that spin through the universe, nature's beautiful artwork. I've always found it fascinating how something so vast and chaotic can end up with such an elegant structure. So, how do these spirals form? One idea that's been floating around is that they might emerge from interference patterns created by elliptical orbits. I'm excited to walk you through this galactic dance. Now, when you've got a bunch of these elliptical orbits going at once, they can start to interfere with each other, kind of like ripples on a pond when you toss in a handful of pebbles. Where the crests of these gravitational waves line up, you get regions of higher density where stuff clumps together. Over time, those interference patterns look like they wind up into the spiral arms we see. It's not the only theory out there, since density waves and galaxy collisions get a lot of love too. But this interference idea is a cool way to imagine the universe sculpting itself. It's important to understand that stars move into the spiral pattern and out again. So let's talk about some galaxies that show off this spiral-making process in action. First up, let's hop over to something young in its spiral development, say, NGC 1300. This is a barred spiral, but it's still figuring itself out. Its arms are just visible and less defined than our older Milky Ways, trailing back as it spins. You can almost imagine those elliptical orbits starting to sync up, the interference patterns carving out the beginnings of those spiral pattern. Next, the Milky Way, our home sweet home. It's got those classic trailing arms, meaning the spiral arms curve backward relative to the direction it's spinning. If you could zoom out and look down on it, sadly, we're stuck inside. You'd see a barred spiral with arms that sweep out behind the rotation, like streamers trailing a acro-gymnast spinning around. The Milky Way's been at this spiral game for a while, so it's pretty well defined. But not all spiral arms trail. Some galaxies have leading arms where the spirals curve forward into the direction of rotation. Take NGC 4622, for example. This one's a bit of a rebel. It's got a mix of spiral features, but some of its arms lead the charge, bending ahead of the spin. But just watch the simulation carefully. Older galaxies that have been around for more than 120 galactic years show this leading spiral pattern without any manipulation of the images, via straight-up simulation. So, what ties all these galaxies together? Whether their arms trail like the Milky Ways or lead like NGC 4622's, the idea of elliptical orbits interfering and creating Moire patterns could be a piece of the puzzle. Early on, a galaxy might be a chaotic blob of stars and gas with orbits aligning. As eons goes by and Einstein's precession works its magic, the ellipses go out of sync and the Moire patterns emerge. The universe is an amazing living artwork.